Assalamu alaikum warahmatullahi wabarakatuh. Good day everyone. This is your host Amr Hassan Usman welcoming you to another episode of From the Beginning. Today's episode is a part of the mini-series PT number 2, which is completed by our brilliant hosts from section STEM 12-2 Chemists, so do check out their videos. Each chemist gave their own tutorials, their own and unique personal touch, so learning will be fun. So for this video, we'll be tackling 3 topics. Firstly, we'll be discussing on one way of expressing a solution's concentration, which is molality. Secondly, we'll be talking about the freezing point depression, which is a colligative property of a solution. And thirdly, about thermochemistry, we'll be tackling about the first law of thermodynamics. So without further ado, let's get started. Molality, also called molar concentration, is the amount of substance dissolved in a certain mass of solvent. This is a property of solution defined as the number of moles of solute per kilogram of solvent. So the formula for molality is equals to moles of solute over kilograms of solvent. To further understand the molality of a solution, let's solve problem number 1. Say for example, you want to drink a cup of juice, so you decide to go to the kitchen but find out that you ran out of your favorite juice powder. You're too lazy to buy outside, so you decide that sweet water will be okay. You add 100 grams of sugar to 1 kilogram of water and mix it thoroughly. What is the molality of a solution? The molar mass of sugar is 342.3 grams per mole. So for this problem and the problems we're going to be solving later, we're going to be using a systematic process. Firstly, we're going to be listing the given for convenience in viewing. Secondly, we're going to be determining the formula needed. Thirdly, we're going to convert what needs to be converted, and if none, we're going to proceed to the second step, which would be to solve the problem. So for problem number 1, first step is to list the givens for the problem. The given in this step is 1. The mass of the sugar, which is 100 grams, 2. The mass of the water, which is 1 kilogram, and thirdly, the molar mass of sugar, which is 342.3 grams per mole. Second step is to determine the formula. So as stated earlier, the formula for molality is moles of solute over kilogram of solvent. Third step is to convert the mass of solute to its number of moles. So using its molar mass, 100 grams of sugar times 1 mole of sugar over 342 grams of sugar would be equals to 0.292 mole of sugar. Lastly, we're going to use the formula to solve for the molality. So molality is equals to moles of solute over kilograms of solvent. Molality is equals to 0.292 mole C12H22O11 over 1 kilogram H2O, which yields that molality is equals to 0.292 mole per kilogram or 0.292 molal. Freezing point depression, as its name suggests, is concerned with the lowering of freezing point with the addition of solute. The more solute is added, the lower the freezing point of the solvent will become. Like other colligative properties, freezing point does not depend on what the solute is, rather it depends on how much solute is added. So the formula for freezing point depression is the following. Delta T is equals to KFM. After satisfying your craving in problem number 1, you realize that you made too much sweet water for you to drink. To make up for not thinking first before making a liter of water that may cause tonsillitis, you decided to freeze the remaining mixture to make sweet ice candy for tomorrow. Since you added sugar to water, the solution's freezing point changed. Calculate the new freezing point of the solution. The Kf of water is 1.86 degrees Celsius per molality. So to solve this problem, Firstly, we're going to list the given for the problem. So given is molality, which we got from problem number 1, is equals to 0.292 mole per kilogram. And the Kf of water is 1.86 degrees Celsius per molal. Step number 2, to determine the formula, delta Tf is equals to Kfm. And since there are no things needed to be converted, we'll solve the problem directly. So using the formula, delta Tf is equals to Kfm, delta Tf is equals to 1.86 degrees Celsius per molal times 0.292 molal, which would be equals to 0.543 degrees Celsius. So the new freezing point of the given sweet water is negative 0.543 degrees Celsius. Proceeding to the third topic, we're going to be tackling about the first law of thermodynamics. The first law of thermodynamics is also known as the law of conservation of energy. It states that energy can neither be created nor destroyed. Energy can only be transferred or changed from one form to another. The law also states that energy can be converted from one form to another with the interaction of heat, work, and internal energy. So the formula for this law of thermodynamics is delta E is equals to Q plus W. So delta E is equals to Q plus W, where delta E is the change in internal energy, Q is the heat, and W is for work. Now we need to take note here what kind of prepositions are used in the problem. If the preposition indicates that the heat was absorbed by the system, then the heat would be positive. However, if the preposition dictates that the heat was lost, then the heat would be negative. Similar goes to work. If work is done on the system, then work would be positive. If work is done by the system, then the work would be negative. So to understand this further, let's solve problem number 3. A certain gas loses 150 joule of heat to its surroundings due to the 50 joule work done on it. Calculate the change in internal energy. So firstly, we're going to list the given. The Q here would be, since the gas loses 150 joule of heat, then the Q here would be negative 150. And since the gas has work done on it, then the work would be positive. So we have here Q is equals to negative 150 joules and W is equals to 50 joules. Next step is we're going to determine the formula. So as stated in the previous slide, delta E is equals to Q plus W. Since there are no things needed to be converted, we're going to directly solve the problem. Delta E is equals to Q plus W. Delta E is equals to negative 150 joules plus 50 joules, resulting to a result of negative 100 joules. So that would be our final answer. That's it guys for today's video. Thanks a lot for watching and I hope you learned a lot from this. Don't forget to like and click subscribe if you loved the video. See you next time!